Alright, on this part, we've got the other type of problem, which is an AND problem. AND problems are conjunctions where the values of x work with two inequalities. AND problems are always when we have a less than symbol. We'll see that on this problem here. So the first thing we want to do is same as the others, isolate the absolute value. So the opposite of a minus 1 3/10 is a plus 1 3/10. So we'll add that to both sides. Now when we do that, we're still left with this 2 being multiplied by the absolute value of x. It's still less than, but when we add this stuff together, we have to carry the 1, and we end up with 6. So now what we're going to do is we're going to eliminate this 2 by doing the opposite of times by 2, which is divide by 2. And when we do that, we're left with the absolute value of x, and it is less than 3. So now let's take a look at the less than types of problems and see why they're an AND problem or a conjunction. Because when we look for values of x that are less than 3, we want numbers like 2. See, if we took the absolute value of 2, that is going to equal 2, and 2 is less than 3. That's true. Or if we took maybe like a number like negative 2, and we took its absolute value, we also get 2, and that value is also less than 3. So this time, we want numbers that are, instead of bigger than the positive, we want numbers that are smaller than the bigger number, and we want numbers that are going to be bigger than the smaller endpoint. So let's go ahead and write out our inequality that we'd have to match that. X is going to be less than 3, but greater than negative 3. And when we go ahead and graph this, we'll draw our number line. We'll put negative 3 on the left and 3 on the right. Open circles again on these two numbers. And when we read it off, it says x is greater than negative 3. Open towards the x. So greater means to the right. Now if we look at this part right here, it says x is less than 3. It points to the x. So that means we would go to the left. And the two inequalities come together. They meet. They are called conjunctions, or they are AND statements. AND means it works with one and the other. And so the way we'll write the answer is just as it is above. And so our answer graphically is here. Our answer algebraically is just negative 3 is less than x, and x is less than 3. So this means the values of x are greater than the negative, but smaller than the positive, which means they're in between. Well, let's try another one. Call this one number 5. And we'll start with how about a 2x plus 1 inside absolute value bars. And we'll say it is less than or equal to, let's go with a 9 this time. So what we want to do is we want to isolate the absolute value like we did here, but it's already isolated. See, this positive 1 is inside the absolute value bars. So we're ready to set up our problem. We're going to figure out the values of x that make it either 9 or negative 9. So the way we're going to do that is set 2x plus 1 less than or equal to 9, but greater than or equal to negative 9. And now we're going to solve for those values of x that make that the case. So the way we'll do that is do opposite operations. So this is a positive 1. To undo that, we're going to take 1 away. And so we do that on both sides. And what we're left here with is a negative 10. Negative 10 is less than or equal to 2x, which is less than or equal to 8. So notice that these were opposite signs, so I subtracted. Here they are the same signs, so I added the two numbers. Well, we got one more operation to figure out the end points of our inequality here. We're just going to divide by 2. And when we do that, what we'll have is this negative 5 is less than or equal to x, but x is less than or equal to 4. It looks as though I forgot to put that inequality sign correct here, so this should be a less than or equal to. Well, we've gone ahead and solved, and now we can go ahead and graph. So we'll stick the negative 5 off on the left-hand side, the positive 4 on the right. And this time we have filled in circles to represent that those two values, negative 5 and 4, are solutions for x. So when we go ahead and graph this, we've got the values of x that are greater than or equal to negative 5. So greater than means we're going to draw the line off to the right side. So greater is to the right. But over here, it says x is less than 4. Less than means to the left. And so the values of x need to be in between two numbers. They need to be in between 4 and negative 5, including those values as well. And so, since they are in between, we can write the answer as the values of x being greater than negative 5 and less than or equal to 4 in between. The values of x are in between. That's why we can write it as one inequality like this, instead of two separate ones with the word or between. So those are the two different types of problems. So just to go back and talk about that a little bit, we've got our AND problems. AND problems are the ones that we just did here, and these are always ones where the absolute value of x is less than or equal to. And then we had the OR problems. OR problems are where they go apart, and that's when the absolute value of x is greater than, or it could be greater than or equal to a number. And so less than means an AND problem, or in between. Greater than means that it's going to be an OR problem, or apart.